Thank you for having me today. I heard that also the second room is watching this presentation. The quick agenda, I know that you don't have any kind of else play to be, so I'll talk about the problems with the full stack teams, and especially in the terms of containerization. I will tell about the Cloud Native Buildpacks from the developer perspective, because I believe that's the most important one in the DevX. How the Cloud Native Buildpacks are built, how I implemented them in one organizations. Does it run on the Kubernetes? Because let's be honest, that's the most important question for today's conference. And I will stop with the conclusions for that. So why this topic? There is the data from 2021. I know, a little bit stale, but it shows that 50% of organizations have around or more than 5,000 containers in production environment. Anybody work with that kind of workload? Okay, 3,000 containers in production. 2,000, yeah, we see some, yeah. So that's huge amount of containers that are running in production concurrently. But there's a disproportion. On the other side of this coin is the fact that 30% of organizations don't have even two containers to wrap against each other. And, if they don't have it, they probably don't know how to use it or use it not as they should. So what is my perspective? My perspective is consulting is that it's difficult, I would say. And not that long ago, 2-3 years ago, I still had to teach companies how to use containers, like from the complete basics, how they're different from the virtual machines, that they have layers like ogres and onions, and how to use them, how to use the tooling, the linters, the CI/CD process, how to build application that will be targeted to be cloud native. And the worst part is that in some bigger organizations, like for example banks, you have few departments, and one department can do awesome stuff like Kubernetes on the cloud with full-blown CI/CD, with all the tooling, GitOps, you name it, they will have it. And few desks behind him will see the guy who is still deploying his PHP application on the virtual machine that's running on premise. And then they don't know about each other, they don't never talk. And yeah, the company is of course running its work on Kubernetes, but your crucial application for the banking is still running on the on-prem. Nobody will tell you about it. So for me, I work for many companies of over 20 clients. I work for different industries, C4ISR, air defense systems for the Industry 4.0, for the banking, loyalty apps, for the insurance, billing societies. I've been doing also a bit of the e-gambling, and I've been building community and logistic companies. Mostly I'm freelancing, and I'll tell you the story as old as containers in most organizations. In 5 steps, remember, there are 5 steps. And trigger warning, do you have DevOps here, platform engineers, SREs? Do you have it? Yeah, quite a lot. So yeah, trigger warning, because I will tell the horror stories that you all know. There was a little bit PTSD for you. So first step is that how hard can it be to containerize your applications? Let's say you have one sprint to do that. You watch a few YouTube tutorials, you ask ChatGPT, you watch articles, and in one sprint, boom, your application is containerized. Success, right? Have you seen that? But of course, it's not like that. We all know that you cannot build something in one sprint from the zero to hero. Most of the tutorials omit good practices. Sometimes they're even showing anti-patterns to make up to speed. Was doing presentation in past 2 years about the good practices in Docker itself, in containerization. I counted 35 language agnostic good practices with containers. I doubt that in one sprint someone can come up with that without some kind of external help. But let's go to second step. Second step is adoption. So somebody did a Dockerfile, somebody else copied it to the project. Let's not reinvent the wheel, right? Let's start doing that. Let's start doing something else, more important, writing code. That's more important for the developers. And this Dockerfile copied each time without changes starts to look like a crumpled piece of paper with your homework that you borrowed, right? But there is a plus, because at least it's consistent when you copy that. It's an old enemy, but it's old enemy. And it's that better always that one that is unknown. So there comes the cancer. it's one more feature, There's always room for more. Our team is special. We need that little feature. So let's do a quick little change, quick little thing. And I will tell you about my favorite consulting horrors. And yeah, that's the trigger one. So I've seen the container with over 120 layers. Almost all of them. Why? It was one stage and wanted to do everything. Why not use all of them? I've seen the container that was running, one container. It was running application, database, SSH server, and it was one container. Why? Well, I think you know why. They just shifted from the virtual machine. I've seen the containers that were downloading binaries at the runtime, depending on the environment variable. So if we were with environment prod, and that was our environment, then we downloaded additional binaries to the container. And of course, it made debugging a horror. I've seen the containers that were spin up for about 10 minutes, 15 minutes before they even could serve traffic. I've seen the containers that just failed if another was not ready. I've seen a Dockerfile with a single monolithic run instruction because somebody heard that if you have few layers, then it's better. So let's just have one and do everything with that. I won't even start about 4 gigabytes of node modules. But if you see and notice, each of those are made by a different person. And most probably, those persons are no longer in the company, so you cannot ask them about it. And here comes the 4th step. Let's make a new one because somebody was not properly onboarded, or maybe he wants to start a new standard. And there's new geological layer of new containerization approach that spans another 3 of these horrors. But I said there are 5 steps and there are only 4 here. Anybody has an idea what's the 5th step?
3.
It's ops problems now. Active development has stopped and it has to be rolling, So who took that personally? That it's ops problems now? Nobody? Yeah, at least few are honest. Yeah, it also pisses me off. But that's the reality. It's our work to make it work. But with all this kind of different Dockerfiles and containerization technologies and approaches, if you have small DevOps team, then their responsibilities is getting really wild and very, very, very thin. And with that, the cognitive load of doing changes increases. For example, I was once approached by the developer who asked me to help him with upgrading the Docker image for Node from 12 to 18th. Quite a big step, right? But they didn't have time for 8 years to do that. So he asked me and told me that that needs to be done for tomorrow because tomorrow is the demo day. And of course, he had 2 weeks and you are given less than a business day to solve it. So you dive into it and I found out that one of the libraries that were used for this Node.js application was relying on obsolete operating system library, which was of course updated with the new Node.js image. And going back would be security risk. And this library was only 40 lines of code. So finding that took me about 6 hours and another 15 minutes to convincing the developer that if he wants to show his demo tomorrow, then he have to copy this library to itself because we won't downgrade operating system for him. So that were the horrors. And I have still 20 minutes. So let's talk about the better things. That's the perfect word that I try to sell you, so delete or Dockerfiles exist. Well, yes and no. There's next best thing. It's called Cloud Native Buildpacks. Here is the link to it, buildpacks.io. And what's important is that it's Cloud Native Computing Foundation. Why is that good? Well, let's look at the dev perspective. From the dev perspective, when she or he will use this technology, he will just use this one command. Just this one native command that will build something without the need of Dockerfile and without any kind of knowledge or containers. the dev will just tell it to build, and it will build a production-ready container that's up to date. All you need is just this command, container engine like Docker Podman, and the pack binary. This command can be even shorter if you use one config that's mostly just metadata with, at the bottom, the environment variables to control the building process, if you need those. And at the end, it's production-ready container with all the good practices and all the checks in place. It looks like magic, and it is a bit of magic. And I will show you here the project. So I have here the Node.js project that's downloaded from some kind of repo. It doesn't have any kind of Docker file, but it's clearly seen it's that Node.js because of the package JSON. And I'm here using the Google Buildpacks that's readily available to build something. And it's analyzing my code after pulling the image. It's building my image because it understood that this Node.js application and exporting this image without the Docker file, with all the good practices that Docker baked and the Google baked. And I have right here my image, and I will run it, but of course it will fail because I don't have set up here the databases and the caching. So the application will run, but it won't serve traffic. Okay. What programming languages does it support? Because I show you here the Node.js. The short answer is yes. So it can support the Java, Go, Node.js, Python, Ruby, C++, C#. The longer answer is that it will support everything that you will support. So yeah, is it good? Yeah, it's great. By the definition, it's a container with binaries that analyze your code and build an OCI compliant image without a Docker file. So you control how you build the containers in your organization. It's like magic. So let's see here the anatomy of Cloud Native Buildpacks. We have multiple buildpacks that are tailored to your needs, some config, and you have the app image at the end. Let's look at the most important one. So one small buildpack. It's only two binaries, detect and build. Do not mistake that with search and destroy. It's detect and build. Detect binary, the script that checks if buildpack should run, if it should build. And the build binary knows how to build each tag that you support as a developer of Cloud Native Buildpacks. How they know? Because you tell them to, as a platform developer. So usually, one buildpack looks like that. It just two binaries, detect and build, with a little bit of configuration. So idea of this buildpack and the name and the version. Nothing complicated. It's that simple. And it's packed in the builder. And the builder is something that has the reference to the build image, so operating system that will build your technology. The run image, so the image that will be put on top of the application to run it. That's the minimal image, as you know from the good practices. It also supports all the ordered lists of your build packs, and at the end, all the binaries for the lifecycle, which are automated when you build the build pack, so you don't have to think about it. And it's just one configuration. You have trusted build packs from the Google, Heroku, and Paketo, and you can use them, of course, as a start or as an inspiration. Should I end the presentation here? I think not, because as a DevOps with trust issues, I like to have the control of my own containerization. So, for example, Google killed already almost 300 projects, and I don't want to be the next of them. And the second part is really important, that you with the build packs, you are really control of what you can do and how are you doing that. So you are either doing it the Google way to build your application, or you can choose the highway, so do it on your own. And the real life story of my implementation is that there was organization. And in 1 year, it grew almost 300 repositories. Some of those repositories were without the Docker file. Some of them were with one Docker file, and sometimes there were monorepo with few Docker files that were building different kinds of tech. 300 repositories in 1 year. And of course, the number of achieved ones wasn't growing that fast. So we had almost 200 more repositories that are in the active development. What about the team then? Surely the team grew, right? Nope. We only had one new developer, so 1% of the workforce, and we even lost one DevOps who just said. So let's talk about our DevOps team. Why I choose the bear? Because we are cuddly when we like you. When we don't like you, we're like the cocaine bear. But most of all, we like honey, right? So we decided to go with the Cloud Native Buildpacks. And we decided that because we wanted to go the platform engineer way. So make everything easy and transparent for everyone in the whole organization. Create the standard for everyone so they can go with the golden pass, with the good guardrails, and they don't have to worry about that. And support everything with 80-20 rule, because we want to support 80% of use cases, and we don't want to spend additional 20% of use cases another 100% of effort. And one lesson I want to give you is that you can indeed enforce best practices by default. Just take away the right permissions. Now, start with the picking language. And this language should be something that you know the requirements the best, and you have most champions in this language. It will be a plus. It also will be a language that has the most value streams in the company. For most companies, it will be what programming language? Java, exactly. You know how it is. Yeah, we chose Java because it has the most repositories in that. And we created small POC with basic structure, really basic. So we have our build packs for Java with only 2 binaries. And I wanted to show a little bit of demo how is it written, but the more I done that it more was about writing the functional scripts with bash with the tail rules. So let's not go with that. You can use any kind of language that has the functionality of return codes. And you can write in those detect and build with Python, with Go, with anything. So only 2 code scripts I will show today are those. First of all, here's the detect script. As you can see in line 18, it's just checking if there is POM XML file here. If not, then the build path will exit and tell it that this build path shouldn't be run. But if there is POM XML file, it will add this build pack to the plan of the build. And for the build binary, it will be too long. It's just building everything that you've done on your console. This is the POC, so it is enough. But it's also boring. So you create the configuration with TML. And you have your first builder, which is only telling that we have this build packs. It's only demo Java for now. And we have reference to build image and run image. How we get those images? With simple Dockerfile. I lied to you. You will need some Dockerfiles in your repository. But it's much easier because with the build image and the run image, it's only one for the whole organization. It won't be copied. You have the whole control through it, and you will have only one instance of it. So it's much easier to just create the Docker file with that and have it stored somewhere else. This will scale better. So you push the builder to your favorite repository, and with one command, you are building your first cloud native build pack. And you can just use this command, and all the Java applications will be built as you want it. Up to date, without the different Git tricks to make everything up to date, without the enforcing. If someone is using this build pack, because that's the only build pack in your organization, then it will run. And what's the lifecycle for the code? Well, we have code. Then we analyze this code. So we are checking, do we have access to the build pack, to the repository? If everything is okay, then we detect which build pack should be running. Then we build and we export the image. But of course, it wouldn't be a good technology if it weren't for the caching. So also, yes, there is caching in this technology, so you don't have to build everything each time we are going through the build packs. Was the DevOps success? No, it was only a start. So this is really bad script, of course, one and huge. But we can just break it down in the Unix philosophy and create more small build packs that are really doing only one thing and doing it well. With that, you have more build packs, but you have more control of it, and it's easier to work with. In the example of expanding, we wanted to create also the build pack that will create the software bill of materials. So we just added new build pack, enhancing software one build pack at a time. Now, the Go developers came to us and asked, can you do a build pack for us? And we thought about it. There were many Go repositories there. So we said, yes, of course. And we make a new one, also starting with the POC. And we repeated that a few times. But then came the PHP developers and asked for that. And we said no. Because what's really important for me with platform engineering is that we don't have to cover 100% of use cases. It would be too much work and it would create worse solution. Just create the golden path with the guardrails and allow people to go from this golden path if they really need one and they cannot accommodate to what you created as a default best patterns. And of course, should you build pack everything? No. As I mentioned, build and run images are the best candidates to be in Dockerfile. Your container with the Terraform, that's also only one organization and is building all your infrastructure as a code in CI/CD. It's a great example of having that in Dockerfile. But those are rare, individual, and short-lived cases. For the developers, cloud-native build packs, I believe, are much better. And what's the ending? The ending is that we grew. So in the first month, we had one repository using all build packs, but we talked with our Java champion to iron out the problems, and we managed to do that. And the next month, 90 repositories were using the build packs instead of Dockerfiles. Then was December, so we didn't move at all, almost. And then we introduced the Go and Node.js, and those 112 repositories still using the old way were both the repositories with the Dockerfiles, but also repositories without the need of containerization, and repositories that were just, for example, snippets or sandboxes. And we kept everyone happy. We kept developers happy because they didn't need to maintain the Dockerfiles and could run the code. We keep the DevOps happy because we could update how we built our software for one place. And we kept the business happy because everybody was doing their job to their best ability. Onboarding costs were slashed, systems were well maintained, everybody was happy. So now, most important question, does it run on the Kubernetes? Yes, it does, with Kpack. So we create 4 objects in the Kubernetes that looks like that. It's just plain YAML that's everybody accustomed to, and we'll just do the same. But the most important feature of the build packs, I believe, is this. Usually, you just export the image, build the image, and you launch it. But with build packs, you can also rebase it. What is rebasing, you ask? Well, with classical Dockerfiles, you build it like that. The first one is the run image, then is your runtime dependencies that you do with the install, then there is your application called the next layer, and the configuration. That's fine, of course, but the build packs turn that around. So the first layer is your application layer. Then you have your runtime dependencies, then the run image, and then the configuration. Why? Because if your run image is somewhat obsolete, it has security issues. We don't want to use it anymore. We can just swap the image without rebuilding the code. Why is that important, you ask? In some regulated markets and industries, each time you rebuild the application code, you need to certify it. And it's really expensive, so you don't want to do that. One certification can cost, for example, 5,000 euros. If you need to change this image in 10 projects, in 10 containers, you would have to either take the risks with outdated images or pay 50,000 euros. No organization wants to do that. But that was the strongest. What about the weaknesses? First of all, the weakness is 0 timestamps. So application will be created in the first second of the Unix epoch. That's the feature, unfortunately, but it's required for the rebasing. It has the learning curve, and I won't lie to you. it is much steeper than Dockerfiles. You will need to write and maintain the code scripts, imperative code, detect and build, search and destroy, you know? Now, you need to make the hard choices. What will you support and what you won't? And that's something that management doesn't like. But you have to do it if you want to keep sane. And you won't have the nice pipelines. If you like that in your Jenkins or GitHub Actions, you can, but it's not the way. You have to just work around this. There's no clear path for testing code and testing security and the linting because it's still incubating at CNCF for 4 years right now, or 5. It's still not a technology rather, so it's quite a new technology that is just gaining traction. And what's a weakness and a feature is that at build and runtime, you cannot install any OS packages. So nobody will break out of your path. That's also a minus, because if you will need a new cloud native build pack, if you will need a new OS system for your run image or build image, you need to rebuild this whole cloud native build pack builder. So yeah, you can enforce best practices by default. It won't be easy, but it's worth it. So closing words, because I have 3.5 minutes. Most important thing, that's me. Remember me and copy the QR code, get me on socials. I will happily take maybe 1 or 2 questions and I'll be happy to talk after my presentation and at the after party.